know that when we solve equations, we need to isolate our variables. But when we have equations that have more than one operation, how do we know which operation to use? Well, we are going to isolate variables by using the order of operations in reverse. We know that typically the order of operations tells us that we would use grouping symbols, then exponents, then multiplying or dividing, then adding or subtracting. But when we are solving an equation, we're actually working backwards. So instead, we're going to add or subtract first, followed by multiplying or dividing, then any exponents or grouping symbols if they exist. So let's look at an example to see what we mean. This problem says 4x minus 8 equals negative 20. When I say that I need to isolate my variable, it means that it needs to be by itself on one side of the equation. Remember that our equation is being broken into two sides based on this equal sign. So one side of my equation says 4x minus 8, and the other side says negative 20. I notice that x has both a 4 and 8 with it on the left side of the equation. Well, how do I know which one to get rid of first? 4 is being multiplied by x, and 8 is being subtracted. Normally, the order of operations tells us that multiplying comes before subtracting. But since I'm undoing my equation, I'm working backwards, which means I'm using the order of operations in reverse. So that means I need to address this minus 8 first. I'm going to solve this just like any other equation. I'm going to use inverse operations. So the inverse of subtracting 8 is adding 8, which I'm going to do on both sides. Now over here, we see that we have what is technically a negative 8 plus positive 8. Well, these are additive inverses, so they combine to make 0, which means I'm left with 4x on this side of my equation. Now I'm going to bring down my equal sign, and on this side of my equation, I'm going to add negative 20 plus positive 8. Negative 20 plus positive 8 gives me negative 12. Now I need to divide by 4 since 4 is being multiplied by x. The inverse of multiplying by 4 is dividing by 4, and I'm going to do that on both sides of my equation. These 4's will cancel, which will leave me with x equals, and then I'm going to solve negative 12 divided by positive 4. I know that negative 12 divided by positive 4 gives me a value of negative 3. This means that x equals negative 3. Remember, when we have an equation, we can always check our work by plugging in our solution to our original equation. So our original equation said 4x minus 8 equals negative 20. I can plug in negative 3 for x to see if this works. So I would write 4 times negative 3 minus 8 equals negative 20. 4 times negative 3 is negative 12, and then I rewrite the rest of the equation. And negative 12 minus negative 8 gives me negative 20. So since I'm left with a balanced equation over here, that means that my solution of x equals negative 3 is correct. Now let's try negative 6x minus 10 equals 32. Again, I need to get my variable by itself. And on this side of the equation, I see that there is a negative 6 being multiplied by x and 10 being subtracted. Well, I need to do the inverse operation, but which one of these do I need to remove first? Since I'm using the order of operations in reverse, I'm going to get rid of my subtracting before I get rid of my multiplying. So, since I'm subtracting 10 over here, I'm going to add 10 on both sides so that I'm using the inverse operation. This is a negative 10 plus a positive 10, which combines to make 0, so they are additive inverses. And now I'm going to bring down my negative 6x and my equal sign. On this side, I'm going to add 32 plus 10, which gives me 42. Now, all I have with x is my negative 6. I still need to get rid of that, and I notice that negative 6 is being multiplied by x, so the inverse of multiplying by negative 6 is dividing by negative 6, which I'm going to do on both sides of my equation. My negative 6's will cancel to leave me with x, and then my equal sign, and I have positive 42 divided by negative 6, which gives me negative 7. So my solution is x equals negative 7. Again, we can always check our work with an equation. My original equation said negative 6x minus 10 equals 32. I can plug in negative 7 for x, so negative 6 times negative 7 minus 10 equals 32. If I multiply negative 6 times negative 7, I would get positive 42. And then if I subtract 42 minus 10, I would get 32. So since this is balanced, my solution of x equals negative 7 is correct. Now let's look at this problem. It says x over 4 minus 5 equals negative 4. I notice that x is on the left side of my equation with both a 4 and a 5. So I need to get rid of these. Well, x is being divided by 4, which I can tell because it's in a fraction, and then I'm subtracting 5. So since I'm using the order of operations in reverse, I'm going to actually address my subtraction first. So I'm going to use the inverse of subtracting 5, which is adding 5 on both sides of this equation. Now negative 5 plus positive 5 combines to make 0, so they cancel each other out, and I'm left with x over 4. On this side, I have negative 4 plus positive 5, which gives me 1. Now I still have 4 with my x, so I need to get rid of my 4 by multiplying by 4 on both sides, because multiplying is the inverse of dividing by 4. So these 4's will combine to make a quantity of 1, and 1x just leaves me with x. Then 1 times 4 gives me 4. So I'm going to say that x is equal to 4. Again, I can always check my work. So my original equation said x over 4 minus 5 equals negative 4. I'm going to plug in 4 for x. So 4 over 4 minus 5 equals negative 4. I would divide 4 over 4 is 1. And then I would write the rest of this. And then I would solve 1 minus 5, which would give me negative 4. Since this is balanced, that means that my solution of x equals 4 is correct. Now let's look at x over negative 11 plus 14 equals 10. On my left side of the equation, I have a negative 11 and a 14. I need to get x by itself, so I need to get rid of both of these numbers. I'm going to start with my adding. So I'm going to use the inverse of adding 14, which is subtracting 14 from both sides of this equation. 14 minus 14 cancels each other out because they combine to make 0, and I'm left with x over negative 11 on this side of my equation. I'm going to bring down my equal sign, and then on this side, I'm going to subtract 10 minus 14. 10 minus 14 gives me negative 4. Now I need to get x by itself, and I see that x is being divided by negative 11, so the inverse of dividing by negative 11 is multiplying by negative 11, which I'm going to do on both sides of my equation. These will cancel to make 1, so I'm left with just 1x, which is x, and negative 4 times negative 11 gives me positive 44. So my value of x here is positive 44. We can check this by plugging into my original equation, which said x over negative 11 plus 14 equals 10. I would plug in 44 for x and then write the rest of my equation. I'm going to divide positive 44 divided by negative 11, which gives me negative 4. Then I'm going to add negative 4 plus positive 14. Negative 4 plus positive 14 gives me 10. So that means that this equation is balanced. So my solution of x equals 44 is correct.